Today we're kind of just tying a bow on everything we've been talking about with linear equations. And we're going to look at simply how to model linear equations. Actually, all along we've kind of been doing that. Modeling simply means taking a real world situation and describing it with math, describing it with algebra. Even more than that, once we represent that real world situation algebraically, we're going to create an equation and we're going to actually look at the solution we found. And one of the things we're going to need to determine is, well, is our solution viable? Or in other words, is our solution, does it make sense? Is it a solution that will work or something else? So that's kind of the goal of what we're doing today. All right. So there are a lot of words here. I want to help you out a little bit. I want to simplify things just a wee bit. So here's what I want you to write down for number one, okay? First of all, we want to just really identify the slope and y-intercept. And so we've got a movie streaming service. So just write down the word streaming service. And they charge $15 plus $4 per movie. That's all you have to write down there. So we'll kind of abbreviate that and make it a little easier for you to write down. Streaming service charges $5 and then plus $4 per movie. Now, the instructions say create a rule for each and identify the slope and the y-intercept in context, okay? Now here's the thing, both those parts have to be there to create the rule. In other words, the way we're going to create a rule is by using the slope and the y-intercept. Now I want you to think about it just for a moment. If I were to graph this problem, I would say, well, the x-axis is my number of movies. And the y-axis, well, that's the cost. I want you to think about that just for a second. Here's what the problem is saying. It says, when I sign up, I have to pay $15, even if I don't, stream the first movie. But then for every movie I stream, it's going to cost me $4. So I know right up front that if I get this service that I'm going to pay $15, even for not streaming the first movie. That's 0 movie stream. But then what happens? For every movie that I stream, it's going to cost more money. Absolutely. And so that graph's going to kind of look like this. Here's the important thing to find. First of all, we want to know what is the y-intercept, or we kind of use the letter B for that. And then we also want to know what the slope is. Okay, now, before we get started too deep into this, who can tell me what they think the y-intercept is just based on, yes, sir? Yeah, it is. It's 15. Great. In other words, at the start of this graph, base thing we're going to pay is going to be $15. That's where it starts, and that's the y-intercept. Okay. What about a constant rate of change for each movie? What is it? $4. Yes. Okay, so to be honest with you, we can kind of summarize it this way. That initial fee charged, or the amount of, say, water in a pool, or whatever, our starting point will be our y-intercept when we go to write or model a situation with an equation. So if it's a fee charged, y-intercept is going to be the $15. And my constant rate of change, that's how much it's going to change based on, and remember, we call this the independent variable. and the cost is my dependent variable. In other words, my cost is dependent on how many movies I rent. The more I rent, the more it costs. So I got to write a rule. You ready? Here's the rule. The rule is y equals, I'm going to use y equals mx plus b. I'm going to use what we call the slope intercept form because I can easily find the slope and easily find the intercept, y-intercept. So it's y equals 4x plus 15. I just remember, sometimes we get mixed up, that the slope is the what of x?
Coefficient.
Coefficient, yes. The slope is the coefficient of x. It's the number in front of x. And my y-intercept is the plus the constant there, plus 15. All right, so look at number 2. Okay, so a pool has 4 inches of water in it. It's being filled up at a rate of 15 inches per hour. Now think about that if I graphed it. Okay. X-axis, my independent variable. Usually time. Okay. And my y-axis is how deep or the depth of the water. Now, having thought about it kind of like that, somebody tell me, looking at this, and here's what I guess I should tell you what I'd like for you to write down. This problem, I don't expect you to write it all down, but just say a pool has 4 inches of water, right? And it's being filled 15 inches per hour. Those are the pieces of that puzzle you kind of need. So instead of writing that whole problem down in your notes, you can write those portions down. Almost jumped ahead of us. I need to determine what is the y-intercept and what is my constant rate of change, or what I'll often call it. So, yeah, what you got, buddy?
Constant rate of change 15.
Yes.
Your y-intercept is 4.
Yes. Constant rate of change 15, y-intercept is 4. Okay, so let's dive into the deep here. No pun intended. Dylan, can you write the rule for me?
Y equals 4x.
Careful.
Y equals 15x plus 4.
And
Careful there. See, and that's easy done. Okay? I just got to remember, m's got to go in front of x. Constant rate of change got to be the coefficient of x. Just got to remember to put it in the right spot. Easy mistake to make. Also, when I'm talking about writing a rule, guys, I could have written it this way. There's no difference. That's just function notation. The other is just a linear equation. But those are the same. Remember, f of x is the same thing as y. And I like function notation because I can put a value in for x, and I'll know what the x was, and then I'll also know what y is after I solve it, after I substitute the value for x in. But either way, I would accept either answer on this equation. I bet most of you probably use y, wouldn't you? But I'll accept it either way. Question on that? All right, let me give you a couple here to tackle, and I'll let you do these on your own, okay? Same deal. Let me show you what you need to write down. Write down sunflower is planted. All right. Grows at a rate of 1.5 inches per week. Okay, now, second one is the temperature in the town starts at 25. So the temperature, town in Alaska, starts at negative 25 degrees and rises at a rate of 1.5 degrees per hour. Okay, so that's the parts that I want you to write down. Go ahead and find the y-intercept, find the slope of each, and then write a rule or an equation to illustrate each situation. Number 3 is a little bit tricky. You got to think about, yeah, Dylan's got the answer. You got to think about when you plant the seed, how tall is the plant? I think for my y-intercept for number 3, what's an answer, Dylan?
0.
0. You might can make an argument that it's actually underground, so something negative, but we're not going there, okay? So yeah, when you plant it, it hasn't grown. So how much does it grow? What's my rate of change?
1.5.
1.5. Elisa, given these 2 pieces of information, can you write me a rule?
Y equals 1.5x plus 0.
Yeah. Well, y equals 1.5x plus 0. Or you could even write it without the 0. We don't really have to add 0 to something, do we? So I'll accept it either way. Either way would be correct. What about number 4? What do you think?
Y-intercept 25. Negative 25.
Yep. And 25. 1.5 is my rate of change. Increases by 1.5 degrees per hour. If I write a rule for that, what?
Y
equals 1.5
minus 25.
Yeah. And you could say plus a negative 25, or if you don't like double signs, which I don't really care for them, you write 1.5x minus 25. That's correct. You do have it has to either be plus a negative or it has to be subtract. Really, that's negative 25, that's negative 25. And it has to be negative 25 because the temperature starts out at 25 degrees below 0. So yeah, it does have to be negative. Because if it were negative, then you're starting your graph out at positive 25 degrees. And 25 degrees is a lot warmer than 25 degrees, negative 25 degrees. And I've seen negative 25 degrees one time in my life. I don't ever want to see it cold again. My radiator froze on my car. Solid. Wasn't a good scene. And that was here in East Tennessee, of all places. It's only happened once in my lifetime. So it's kind of really, it's kind of a little crazy. I'd walk out and I'd breathe and it just freeze solid fall down. Cold, too cold. Let's look at another one. All right, so create a rule, slope, the y-intercept. Number 5 has a bit of a twist. It's a little bit tricky, so be careful. What I'd like for you to write down is this. I'd like for you to write down that a iTunes card starts out with $25, and you download songs. It costs $1.50 each. Got another pool here. A pool is empty. And we start trying to fill it up. So we fill it up at a rate of 15 inches per hour. Those are the bits and parts I need you to write down. Again, we're going to do the same thing. We're going to find the slope, the y-intercept, write an equation, Katie, I'm gonna ask you about the first one here, number 5, okay? So we got this iTunes card and it starts out, it's got money on it, $25. And then every time I download a song, it deducts $1.50 from that card. What do you think the y-intercept is there?
25.
Katie, your voice sounds different. Yes, 25, that's correct. Okay, cool. Now, I'm betting you get this next question wrong. I'm betting you're not going to get this right. So, what is my rate of change? Guess me.
$1.50.
Ooh, I led you astray. What is it? Is my rate of change $1.50? Think about it.
Yes.
Negative.
What?
A negative $1.
Negative $1.50. See, hey, you got to be careful there because remember, and I'm just going to write 1.5. They're going to subtract the $1.50, aren't they? They're not going to give me money every time I download a song. If I did that, man, that'd be a deal. Apple's too smart for that. They've got it all figured out. So each time that I download a song, they subtract $1.50, so my rate of change is $1.50. And in an equation, well, I think that's probably the easiest part. Y equals negative 1.5x plus 25. Seems pretty simple. Questions? All right, let's look at the last one. Pool is empty. And we start putting water in. If you ever put water in the pool, it takes forever. All right, so what's my y-intercept?
0.
0. Yeah, starts out empty, no water. What's my rate of change?
15.
15, yes. And so it's y equals 15x
Plus 0.
plus 0. Or I don't have to put the plus 0. That's pretty easy, really. Isn't it pretty simple, really, to take a real world situation and model it using what we've learned about linear equations? Well, I want to just bump it up one more notch here, okay? This is example 1. We're gonna kind of take it up a level and talk about how we're going to use this. Okay, so what you probably want to write down is department store offers this frequent flyers buyer's card, okay, to earn rewards for purchases that customers make at the store. Now, each transaction is worth 12 points, and customers automatically earn 25 points when they sign up, okay? So the first thing we've got to think about, and I know the other classes have preferred all day long to just look at it in terms of X and Y. But what a variable do we assign to what? Okay, so for example, if I'm talking about graphic, what determines my X axis? What's my independent variable? And then what is my Y axis? So what do you think? What is independent here in terms of the number of reward points that I get? What's independent? What do you think? Well, let's identify two things that happen here. We get points. What's the other thing? How do we get points? We have to you have to earn it. How do you earn it?
Signing up.
Do what?
By signing up.
By signing up, but then
You have to buy stuff.
you have to buy something. Okay, so here's the thing. When we buy something, okay, we call that transaction. Okay, so when the more I buy, the more, what do I get? Points, right. So what's independent there? And what's dependent? Really, the points that I earn are dependent on how much I
Bye.
buy. Yeah, so what's independent? How much I buy. So my transactions or my purchases or what I buy, transactions, that's my independent variable. In other words, I'm going to say, well, let's let X be the number of transactions or purchases I use the word buy there. So if my transactions are my independent variable, my dependent variable, my Y is what? It's the points, yes. That I earn. So you want to write that down too. Okay, so let X be the number of transactions. And let's let Y be the number of points I earned. Now they're going to throw a little curve. They're going to say write the function rule for the card value as a function of C. Well, you know, I could call transactions T, and I could call points earned C of T. Yeah, I can do that. I can make that transition. Okay, so if that's the case, my transactions then are actually T in the number of points is a function of C of T. They want me to do that. Okay, so I can make that change. That's not a big deal. I understand functions. I need to know before I can write a rule, though. I need to know what is my y-intercept, what is my slope. The slope is 12, yes. The slope is 12. It's 12 points earned every time I buy something, right? What's my y-intercept?
25.
25. Very good. Awesome. I may cry again. Y'all just make me so happy. So if I write it as a function, then I would say C of T, okay, is equal to, and then it's 12x. Okay, remember the slope is going to go with my x. It's the coefficient of x
Yeah.
plus
12.
25. Right. So I've got a function. Awesome. Now, the next part of this question is a little more challenging here, okay? It says this. It says for each 100 points, okay, that the customer earns, they're going to get a gift certificate. Hot dog. How many transactions will it take for the customer to earn the first gift certificate? Well, you know, I don't want to guess, but here's what it's saying. Remember, C of T is the number of points I earn. So what I'm wanting to know is when is C of T or when is Y or however you want to look at it, when is my function 100 points? And so I can just put down 100 points here is equal to, by the way, I made a little mistake. I put X there because I'm so used to using X. It really should be 12T. Okay? I like X and Y better. I'm kind of with you all, but that's what it told us to do. So I want to know how many points. So I'm going to put in 12T plus 25 here. Let me restate what I did. I wanted to know when I had earned 100 points. So I'm putting that 100 in for C of T. And then, of course, no 12T plus 25. So if I solve that equation and find out what t is, it's going to tell me when t is such and such, I've earned 100 points. What I want to do. So I know already, because I can solve equations, that all I have to do is take this plus 25 here and subtract 25. And I need to do that here as well, right? So these cancel out. That's good. That's what I want to have happen. And 100 minus 25 is 75. So now my problem is 75 equals 12t. Now I need to do what? Divide by
12.
right. Divide by 12. Okay, so when I do that, what I get when I take 75 and I divide it by 12, 6.25. Okay, so check it out. Here's what I want you to fill in a blank. Here's the question, okay? Here's the blank. When I make, don't answer yet, blank transactions I will get a gift certificate. Exclamation point, yay. Smiley face. All right, so can you fill in that blank for me? Do what? No? You say 8?
Yeah.
6.
6? No?
I say 4.
When I make blank transactions, the temptation for me would be to answer, when I make 6.25 transactions, because I solved that equation, right? But that answer would be wrong. Why?
Because you can't get half of
For the purchase?
Yeah, I can't do 0.25 of a purchase, can I? That's like I didn't buy the whole stuff, all of it. I just bought a quarter of it, okay? Hey, here's 4 items, I only want one. No, I can't do that. So you got to buy it all, right? They don't let you just buy a piece of it, okay? So when I make what? How many? 7. Yeah. So at 6, I haven't quite hardly made it, but on that 7th transaction, by doggies, I have got my gift certificate. I'm happy. I'm going home smiling. Now, that was, you remember when we first started talking about our standard at the very first of the class, we said, we want to make sure, you remember how that was worded? How the standard was worded?
that you didn't use common sense.
Well, kind of that was the way, that was the meaning. And I believe they used maybe the word viable. Look at that just for a second. Yeah, it says interpret solutions as viable or non-viable, okay? So what I've done here is I've looked at this solution. Whoa, went too far. And I have determined that in my solution, that the 6.5 that I found, or 6.25 that I found, well, it's a correct answer, but it is not mathematically correct, but it's not a viable solution. I have to actually realize, if I get 6, I'm not going to have quite enough points to get that gift certificate. But if I just bump it up to 7, which I can do because I can't get 6.25, then at the 7th one, I've got my gift certificate, and that's what I want to have happen. So that's what the standard's talking about. Do you see things that happen like that in real life? Oh, yeah, you betcha. You know, I've on my phone, I've got no telling how many different apps that are reward apps, you know, Starbucks, Chick-fil-A, McAllister's, you name it. It all seems to be food. I don't know what that says about me. But they are all set up in a similar way. You get some kind of reward after you bought so much stuff. So we want to just be sure that anything we do, we understand whether our solution makes sense and is a viable solution. And that's what we do. When we model real life equations, and we can model those that fit a linear function.